Hi everyone, in this video we're going to show type 1 sample problems for improper integrals. This is example 1. Evaluate the improper integral. The integral from 1 to infinity dx over x raised to 3 over 2. Let us copy this problem down here and we take note that the upper limit here is an infinity. So this is a type 1 improper integral. By this principle, the formula will be the limit of integral from 1 to b dx over x raised to 3 over 2 as b approaches infinity. Applying our power rule of integration, we will have this x raised to negative 1 over 2 all over negative 1 over 2. This will be evaluated for the limits from 1 to b. We can simplify further our fraction here, so we will get negative 2 over the square root of x. Evaluating this fraction by the limits of integration, we will have now negative 2 over the square root of b minus negative 2 over the square root of 1. For the second fraction, the square root of 1 is 1, and negative 2 over 1 is simply negative 2. The negative and the negative will give us positive 2. So we write here plus 2. Now let us evaluate the limit when b approaches infinity. If we substitute infinity in the b, the denominator here will become bigger and bigger, and this fraction will come to 0. So this is now equal to 0 and then the plus 2. 0 plus 2 is simply 2. This is the final answer. Example 2. Evaluate the improper integral. The integral from negative infinity to 0 of the function e raised to 3x dx. Let us copy this integral down here, and because of this negative infinity in the lower limit, this is a type 1 improper integral. So the formula will be the limit of the integral from a to 0 of the function e raised to 3x dx as a approaches negative infinity. The integral of this e raised to 3x dx is simply e raised to 3x over 3, and this will be evaluated with the limits from a to 0. So we will have now this e raised to 3 times 0 all over 3 minus e raised to 3 times a over 3. In the first fraction here, the 3 times 0 is 0. So e raised to 0 is simply 1. So this value here is 1/3. So we write here 1/3 minus the second fraction. Let us now evaluate the limit when a approaches negative infinity. Let us substitute this negative infinity to a. So we will have this result. In the e raised to 3 times negative infinity, we want this exponent to be positive. So we will rationalize it and put it in the denominator. So we will have like this. Now take note of this infinity. When this becomes bigger, the full denominator becomes bigger. And this 1 over the infinite value will come down to 0. So we have 1/3 minus 0. And the final answer will be 1/3. Example 3. Evaluate the improper integral, the integral from negative infinity to positive infinity. The function is 1 over 1 plus x squared dx. Let us copy this integral down here, and because of this negative infinity and positive infinity in the limits, again we say this is a type 1 improper integral. By our formula, we say that this integral is equal to the integral from negative infinity up to 0 of the function plus the integral from 0 to infinity of that function. Next, we evaluate each improper integral on the right side of the equation. Let's begin with the first integral here. Let us copy the integral on this side, and with our formula, this is equal to the limit of the integral from a to 0, 1 over 1 plus x squared dx as a approaches negative infinity. The integral of 1 over 1 plus x squared dx is a special formula, and this will lead to the tangent inverse x. So we write it here. But this must be evaluated with the limits from a to 0. Substituting now, we have tangent inverse 0 minus tangent inverse a. Evaluating the limit as a approaches negative infinity, this tangent inverse 0 will simply 0 minus the tangent inverse a as this a approaches negative infinity will give negative pi over 2. So 0 minus this value will be positive pi over 2. So this is the answer for the first integral. Let us substitute this below that integral. Let us now solve the second integral. Writing this integral again in this side, then we say that this is equal to the limit of the integral from 0 to b of the function 1 over 1 plus x squared dx as b approaches infinity. The integral of this 1 over 1 plus x squared dx, we know that this is equal to tangent inverse x. This time, this will be evaluated on the limits from 0 to b. Substituting the value, we will get tangent inverse b minus tangent inverse 0. Let us now evaluate the limit as b approaches infinity. The tangent inverse b, as this b approaches infinity, will give pi over 2 minus the tangent inverse 0 is simply 0. So the final answer will be pi over 2. This is the answer to the second integral here. Now, let us get the sum. Pi over 2 plus pi over 2 is simply pi. This is the final answer. I hope you learned something from this video. See you again next time.